Okay, welcome to Chapter 8. Chapter 8 is about roots, radicals, and root functions. In other words, radical expressions and radical functions. So, for those of us who don't remember, a radical symbol looks like this. It's the square root sign. I don't like calling it the square root sign because it implies it is only square roots. You can have a radical that is a cube root, a fourth root, an eighth root, whatever you want. And so it's much more powerful than just a square root, okay? But this is the symbol that you'll see, and then we'll talk about the different parts in just a minute. Actually, we'll do it right now. Okay, so it kind of looks like this in general. You've got the square root or the nth root, pardon me, of a is equal to b. What that means is that b to the n is equal to a. So it's kind of the opposite of a square root. A square root undoes a square. Think of it that way. Square roots undo squares. Just like addition undoes subtraction and division undoes multiplication, square roots undo squares, okay? Same thing goes for cubed roots and, fourth roots, fifth roots, sixth roots, and then if you want to just say them all at the same time, we call them nth roots. So, nth roots. Alright, cool. Some terminology. The A part of this, the thing underneath the radical symbol, is called a radicand. Radicand. That's what I'm going to be calling it from now on, so make sure you know that. The nth number is the index or the order. So if you have a third power, then the index, a third root, then the index is 3. If you have a eighth root, then the index would be 8. And then the whole thing together would be called a radical expression. Radical. Not to be confused with rational, right? Those are two different things. Rational versus radical. Okay. Radicals have the radical symbol. Alrighty. Now, since roots undo powers, right? Roots undo powers. Let's take a look at example 1 and see if we can simplify a few of these. So this one, in example A, says the square root of 16. You've probably seen it before. And remember that when you have a square root, right, there is a little invisible 2 here. It's just so common that we are lazy, right? Mathematicians are lazy, and so they don't put the 2 there. They just kind of leave it off. So this is the same thing as the square root of 2, or square root of 16, pardon me. And in other words, what it's asking you is, okay, so if this is equal to b, right, because that's what it says up here, our radicand would be 16, our index would be 2, and our answer is going to be b. So what it's asking is, what b when squared equals 16. That's what it's asking. That's the opposite of the square root of 16, right? So we would square both sides. So what would b be? b is equal to 14. So the square, I'm not 14, sorry, 4. b is equal to 4. So the square root of 16 is equal to 4. That's what it's asking. Okay. Hopefully you've seen that one before. Hopefully you know your squareds. A little bit of memorization there. You've got 2 squared is 4, 9, 16, 25, 36, so on and so forth. And so when you see stuff like that in a radicand setting, you can easily identify, oh, the square root of 16 is 4, right, without having to go to the calculator. If you can't do that, you might want to practice. All right, let's try B. This time we have an index of 3, so it's saying we have a radicand of 64, right, radicand of 64. And we want the cubed root of 64. The index is 3, and we want the cubed root of 64. In other words, if that equals b, then what times itself 3 times? What cubed would be 64? Excuse me. That's the question. So how are we going to find that? Well, we're just going to have to start thinking of things cubed. Well, let's just start with 2. 2 cubed. No, 2 times 2 times 2, that's 8, so it's not that one. 3 cubed is going to be, well, 3 squared is 9, times another 3 would be 27. Nope, not quite that one. 4 cubed would be 4 times 4 is 16, plus times another 4. Ah, that is 64. We found it. So b is equal to 4 in this case. You're welcome to use a calculator if you know how to do cubed roots, but things like that, really, you should kind of know. Just start with 2, 3, and 4. It takes a little bit of identifying, but I think after about, 2 dozen, you'll be able to see things like that. Cubed roots will become very familiar. The fourth roots will become familiar. The eighth or the squares will become familiar. Okay, let's try another one. Here we've got a radicand of 81 and an index of 4. So in other words, if this equals b, we want to know what to the 4th power equals 81. That is the question. Well, let's try with 2. 2 to the 4th. 2 times 2 is 4. 2 times 2 is 8 times 2 is 16. Okay, that's not right. 3 to the 4th. 3 times 3 is 9 times 3 is 27 times 3 is 81. We found it. B is equal to 3. Okay, cool. So you can see how these are pretty straightforward as long as you convert them like that. Just make sure, because when you're looking at this and you ignore the index, it's very easy to say that the 4th root of 81 is 9, right? Because it looks kind of like a square. Don't fall for that trap. Always check your index. Check your index. Your index will tell you what power you need. Okay. Sometimes you get things like D, things looking like D, and they're kind of hard to tackle together. But there is a rule that we will again talk about later that says, it may sound familiar, it's called the quotient rule. If you have one giant radical and a rational underneath, right, a fraction, a rational, then you can split it into 2 radicands and 2 radical expressions, okay? So that's totally legal. It's legal for multiplication and division. It is not legal for addition and subtraction, just like all that stuff with rationals, just like all that stuff with exponents, right? You can do a lot of stuff with multiplication and division, including splitting up like this. Addition and subtraction, not so much. So we'll see that again later. But for right now, let's just apply that rule. And then let's tackle one piece at a time. What's the cubed root of 8? Well, we talked about cubes earlier. 2 cubed is 8. So this must be 2. And what's the cubed root of 27? Again, we talked about that earlier. 3 cubed is 27. So the cubed root of 27 would be 3, right? We're undoing a cube. We're undoing something times itself 3 times. And so we get down to 2/3 as our answer. So if we actually tested that out, 2/3 times 2/3 times 2/3, multiply the tops, multiply the bottoms, you would get 8 over 27 as well. Okay. So let's do another one. Cubed root of 125. Cubed root of 125. In other words, if that is equal to b, then b to the 3rd is equal to 125. Well, we've done a lot of thirds today. We know that b to the 4th is 64, and that's smaller, so it can't be 4. Let's try 5. That would be 5 times 5 is 25. Times 5 again would be 125. So it looks like b is equal to 5. There we are. Keep going. The 5th root of 32. A radicand is 32. So in other words, we're asking if b is equal to, or if the 5th root of 32 is equal to b, then b to the 5th must be equal to 32. So what's b? Well, let's see. I know 2 to the 3rd is 8 times, or sorry, I know 2 to the 4th is 16, right? I know 2 to the 4th is 16. Let's try 2 to the 5th. 16 times 2, that's indeed 32. So b must be 2. These whole number ones are pretty much all you're going to see when it comes to solving them by hand. Sorry about that. Anything like the square root of 45 that wouldn't factor down or wouldn't go down to a whole number, you probably won't see here. We can use calculators to figure those ones out. They're just not super exciting, so we won't really be just simplifying them. And honestly, if it's the square root of 45, there's no reason to change it to a non-terminating decimal, so we'll just leave it as such. But things like square root of 16, cubed root or 5th root of 32, since those go down to such nice easy numbers, we're going to be doing those a lot. Another type you might see is a decimal. The 4th root of 0.0016. In other words, what to the 4th power would be 0.016. Okay, well, we've got something that's going to need to be a decimal, right? So b is going to need to be a decimal. 16 tells me there's probably a 2 involved, right? Since 2 to the 4th is 16, or maybe a 4 involved, but let's see, if 2 to the 4th is 16, is a whole 16, then in order to go down 3 spaces, let's try 0.2 to the 4th. That I will definitely use my calculator for. 0.2 times 0.2 times 0.2 times 0.2. It is 0.0016. Oops. Did I write? I didn't write enough zeros. My bad. 0, 0, 1, 6. Yeah, that makes more sense. Okay, cool. So it looks like b is equal to 0.2. Fabulous. So I counted the number of decimal places here to get me to a whole number. It was 4, just like the index, so it led me to a feeling that I had one decimal place I needed to move 4 times. So 0.2. If that hadn't worked, maybe I try 0.02. Maybe I try 0.002 or something like that until I arrive at the indicated radicand, right? Find the indicated radicand. Alrighty. Let's talk about principal roots. So, with radicals, we have to be very careful because there are technically 2 answers. Let's think about this. The opposite of a square root is a square, correct? Right? So the opposite of a square root is a square. Let's think about 36 for a sec. Square root of 36. In other words, if I'm trying to find the square root of 36, then what I'm asking is what squared equals 36, right? That's the question. Many of you will say 6 squared, of course, and you'd be right. 6 squared is equal to 36, but really be cautious because also negative 6 squared is 36. All those negative versions are also roots, right? Because the answer is what squared would be 36? Anything negative times a negative would become a positive. So technically, the answer is both 6 and negative 6. Now the positive one we call the principal root, and that is the one you'll see most often. That is the one that people have become familiar with when they're first learning these. That is the one that makes sense in 99%, not 100, but 99% of our applied problems. But really there are 2. The first one is called the principal root. The second one's called the negative root. Okay, that applies to squares and any other even power. An even power when your radicand is positive. So 36, square root of 36, square root of 49, square root of whatever, 4th root of 36, well not 36, but 4th root of 64, 4th root of 16, right? 4th root of 625, right? So all the 2nd powers, the 4th powers, the 6th powers, the 8th powers, dot, 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 right? But your radicand has to be positive. Then you'll end up with 2 different answers because those things, when you square them, become positive no matter what. When you take something to the 4th power, it's 2 squares, right? So they'll become positive. Negative times a negative, negative times a negative, 4 of them becomes a positive. So you end up with 2 answers. If it's even, we'll come back to that. If it's odd, if that index is odd, there's only one answer. Because when you think about it, I'll do this in a different color. 2 cubed is going to be a positive 8, right? But what happens when you have a negative 2 cubed? Well, it's going to be negative 2 times negative 2, so a positive 4 times a negative 2, that's going to be a negative 8. So we don't have to worry about it with odd powers, because not all, because odd powers of negative numbers don't end up being positive. So negative times a negative times a negative, since there's 3 of them, it stays a negative. So it'd only be one answer, be the cubed root of negative 8, right? Okay. If it's odd, no matter whether, and that doesn't depend on whether the radicand is positive or negative. If it's odd, then it's just the square root of, or it's just the cubed root of whatever you have, right? The nth root of whatever you have. If it's even, so back to the even case, but the radicand is negative, so something like square root of negative 36, or the 4th root of negative 16, these are not even real numbers. And it comes from this idea, right? If everything squared is going to end up being a positive, then there's no negative square root. That doesn't make sense, right? Or sorry, square root of a negative. There's no square root of a negative. If everything's supposed to end up positive, there's no way to get negative 36. Because what you're asking here, let me erase this for a sec. What you're asking here is if you want that, what squared is negative 36, right? That's the question. That doesn't make any sense. Nothing squared can be negative 36. So it's not a real number, okay? Now we're going to come back at the end of the chapter and we're going to deal with stuff like this. It's actually one of my favorite subjects, so we'll talk about that later. But for now, you can just say that it's not a real number. Okay. All right. And that's for any even roots, so 4th roots, 6th roots, 12th roots. Remember, you can have a square root under a third, right? We just saw an example of that. You can have a square root under your third. You can come up with a number that way. Alrighty, let's do some examples. So simplify the following radicals in each to find each root. Identify whether it is the principal root or the negative root, if possible. So if we're dealing with, I believe all of these, nope. So if we're dealing with an even index, right, an even n, then we will figure out whether it's the principal root or the negative root. And there is no principal or negative for odds. So if we just have an odd, we don't have to do that. But let's start with example A here. I have the square root of 100. Radicand is 100. The index is even, it's a 2. So this looks like our principal root. Square root of 100 is 10. Square root of 100 is 10. This would be the principal root, right? The even one. I'm sorry, the positive one. Compared to its neighbor, the square root of 100 is 10. And this one is negative, right? Equals negative 10. This would be our negative root. So you can see it's very easy to identify the difference between the two because one of them has a negative in front. This one did not. This one has no negative in front, right? So it's just jammed right up against A. This one actually has a negative in front. So that's how we distinguish between the two. Whether we want the positive one or the negative one, we throw a negative in front of the radical symbol. Okay. All right, let's do it again. 4th root of 81. I think we've seen this one today. In other words, if this is equal to B, what to the 4th is 81? That's the question. Well, it could be two things, right? It could be 3 or negative 3. And since this does not have a negative front, we are looking for the principal root. This would be our principal. Over here, same concept. This one's going to be our negative, right? Our negative 3. So x is going to be 3 over here, negative 3 over here. And you can tell that because of the negative out in front. Okay, let's try out this one. Cubed root. Cubed root of 8. So we've got the, oops. This is equal to b. B to the 3rd is equal to 8. Well, we don't have two options, right? Because I could say b is 2. But if I say that b is negative 2, I would be incorrect. Because negative 2 times itself 3 times does not equal positive 8. So there is no second answer here. This is not a principal or negative root. It's just the only answer. It's the root. B is 2. Same concept over here, right? Just because it has a negative in front of it doesn't mean it's the negative root. There is no negative root. It's because it's an index of 3. So it really depends on your index, right? It depends on your index. And we just saw from the last example, this one would end up being a negative 2. Negative 2 times itself 3 times. Right? That's the question. 4 times negative 2 would be negative 8. Oops. Yeah, that would be the same thing. Okay. Hopefully that's making sense with principal, negative, and when you actually apply them. Okay, find the nth root of nth powers. So, again, nth just means all of them. So squared, cubed, 4th, 5th, it's just, it's a variable, right? So the nth root would be n and a, something like that, okay? Let's consider again 36, right? Let's consider again 36. So let's say we found out that a is equal to 6, right? Our principal root. What happens when we take a to the nth power and then use the nth radical? What would happen? Well, since roots are opposites of squares, if those two in fact match, they will simply cancel each other out. And that's very, very important when it comes to solving radical equations. So let's see that in action. If a is equal to 6, then a square root of a squared, notice the n here is 2, so 2, 2, right? They match. The indexes are 2. 6 squared would be positive 36. Take the square root of that, you get 6 as our principal root, right? So you end up back where you started. However, if a is a negative, and we do that, right, we take the square root of a squared, then when we put in our negative 6, that becomes a positive 36, and the square root, our principal, would be a positive 6. So in either case, we end up with 6, right? If a was 6 to start with, it became a 6. If it was negative 6 to start with, it became a positive 6. So in other words, when you take the square root of a square you get the absolute value of a. You get the positive version, right? You get the positive version no matter what. Same goes for any even nth root. Any even nth root. Go for odds. We will. Let's stay on squares for a sec. So it definitely works for squares, right? Okay. So now let's try a few of those. So here I have the same thing. I have 7 squared square rooted, right? 7 squared would be 49. And if we stick with the principal root, because that's what it's saying, right? I don't see a negative out there. That would be a 7. 7 is in fact the absolute value of 7. That's good. Let's try another one. Let's jump down to here. Let's do C first. Negative 7 squared. Well, that would be positive 49. Important to note that your calculator, if you type in negative 7 squared, right, it will tell you it's negative 49 because you did not put the parentheses in. Your calculator will make you fail if you try to cheat and do this on your calculator, okay? I will tell you, it will say domain error, it'll say not a real number, it will yell at you many times unless you put those parentheses in. Alright, square root of 49 ends up being a positive 7. So in both cases, we end up getting 7 and 7, right? Just as the theorem told us, we ended up with the absolute value, right? Whether it was a positive 7 or a negative 7 to start, we both ended up with a positive 7. Let's do that with k as well. Now that we know the theorem, we know it's what it's supposed to end up as long as the index and the power in the radicand match, right? As long as the index and this power underneath match, we should end up with just the absolute value, which is k. K squared square rooted? Yep, it's k. Same thing over here. If we have k squared square rooted, we end up with the absolute value of k, negative k, right? Which would be a positive k. So we know that this one should also end up equaling k in both cases. Alrighty. Like I said before, this extends to all even powers. All even powers have the same property, right? And for the same reason. They have a principal and a negative root. Both of those, when you square them, become back to the positive, just like the 36, right? So both of those, 6 and negative 6, both became positive 36. That works for 4th powers, 6th powers, 8th powers, all the same. So that applies to any even power. However, with the odds, remember, it's just equal to a. Since the cubed root of 8 is not a positive to begin with, and neither would the negative 2 cubed, right? When you cube it, it doesn't guarantee it becomes a positive. So the negative version just stays a, no matter what a is. So you can end up with negatives if you have odd indexes, okay? So let's try out a few of those and see what happens. So here we've got a 6th root that's even. I should end up with a positive, right? I should end up with the absolute value. Let's see if we do. So what is negative 3 cubed? Or sorry, negative 3 to the 6th? That would be, oops, and I just did exactly on my calculator what I was told you guys not to. I didn't put it in parentheses, and I got the answer negative 729, which is not right, because it should be positive 729. So this would be now the 6th root of positive 729. Take the 6th root, 729. Nope. Take the It's very important to know how to find higher roots on your calculator. So if you don't know how to do that, then you need to come in and talk to me. We will find it together. If you have one of my calculators, I can easily show you. If not, then we can figure it out. Okay, so I just found out the 6th root of 729 because there's no way in heck I'm going through all of the numbers till I find 6 powers. But I got 3. I got 3. And that's what I'm supposed to get, right? The absolute value of whatever's an a in the radicand. And I did. I got positive 3. Let's try another one. Here I have an odd power. I have an odd power, right? So let's find out what's negative 4 to the 5th. Negative 4 to the 5th is a negative. Yep, it's a negative 1024. Negative 1024. Take the square root of that. Wait, hold on. Okay, so from here I actually can't take the square root, right, because it's negative under the radical. But from the theorem, I know that these two are going to cancel and leave me with just a negative 4. So I'm gonna not do it this way. So from the theorem, those two cancel, and because it's odd, I'm left with a -4, right? Left with a -4. That's by definition. Over here, I've got even powers, right? I'm going to ignore this for just a sec, but I've got the -4th root of -9 to the 4th, right? By the theorem, these two are going to cancel and leave me with, well, it's even power, so absolute value of 9, right? Or -9, which would be 9. But they're asking for the negative root, not the positive root, so it's a -9, right? So I'm going piece by piece. First off, I use the canceling skills, use my theorems up here, and then I identify which root I want. Over here, ooh, this one's tricky. I've got the the square root of m to the 4th. It is no longer matching, right? I've got negative version, but we'll talk about that in a sec. So negative square root of m to the 4th. Well, if I consider m to the 4th as, sorry, one sec, m squared squared, right? Those exponent rules from way back when. M squared squared, then I do have it, right? These two squareds cancel, and I'm left with the negative root of m squared, right? So now I'm just left with -m squared. And it's very important to note that if you wanted to draw parentheses, they'd be there, not around the negative, right? So you can do it, you can essentially take out factors too. You can take out factors from each. Well, let's try another one of those. I've got 3 and 12. Well, if I consider a to the 12th as a to the 4th to the 3rd, then the cubed root part's going to cancel, and I'm just left with the principal root a to the 4th. So it does work no matter what, and this is an odd index to begin with, so since it's an odd index, I didn't have to worry about making it positive. It's not a principal, it's just the root, right? So you can take out factors, take out any factors you need. Let's do one more. For 4th root of x to the 12th, then we can take this and say, okay, well, I need to cancel with something of 4, right? I need to cancel something of 4. How can I split that up? I can do x to the 3rd to the 4th, because 3 times 4 would be 12. Those two cancel. I'm left with x to the 3rd. And if we wanted to be super technical about it, we would say, since this is even, we want the absolute value of x to the 3rd. Absolute value of x to the 3rd. And that would be our final answer. Alrighty. Like I said before, anything that doesn't factor into something, small and easy, like 9 or 6 or 729, something like that, then we can use our calculator, right? But honestly, if it ends up being like a 37-place decimal, you don't need to. It's just better to leave it as a radical anyways. So I would only ask you to reduce stuff that can be reduced prettily, if that's a word. Alright, so that's 8.1. That's our introduction to radicals. I think that's plenty for now. So hopefully this answered your questions. If not, then email me and I will see you in the next video.